So here is a more challenging problem for using equations to solve word problems. So the price of the play is $12 for adults and $8 for students. We know that the theater has 400 people. We know that the play sold out and we made $4,200. And you have to figure out how many adults and how many students were sold. So the first thing that makes this problem hard is there is no statement that says like there are 5 more adult tickets than student tickets sold, or there are 2 times as many. There's no statement like that. We just know that adults plus students has to be 400 people. So in this case, it doesn't actually matter what you let X be. There's not like a statement where there's, twice as many of this as this. So you just get to choose. Do you want X to be students? Do you want X to be adults? It doesn't really matter. I'm going to let X be students. Now, coming up with adults is a bit tricky, but we do know that there's 400 tickets. And if X of them are students, then 400 minus X has to be adults, right? Think about it. If students and adults together is 400, and I know what students is, to get adults, I just have to subtract, right? So let 400 minus X be number of adults. Okay, now I can write my equation, right? Okay, wait, because I can't just say X plus 400 minus X equals 400, because that doesn't make sense, because these statements are number of, and if I make it equal to 400, great, except what is actually going to happen, so X plus 400 minus X is 400. X minus X, that's actually 0. Just cancel. I just get an equation that says 400 equals 400. That isn't helpful. It doesn't help me actually solve anything. So that's not what I want to do. So then you're going to say, oh, okay, but Dr. Annabelle, I know you just make it equal to $4,200. So you say X plus 400 minus X equals $4,200. The problem is that these represent the number of people, and this represents money. Those aren't the same thing. You can't say this many people equals this much money. They aren't equivalent. That's what makes this a more challenging problem. What you have to do is take number of students and number of adults and turn that into money. Well, how do you do that? Well, if each student was $8 and there are X student tickets, the total of money would just be $8 times the number of student tickets, which in this case is X, 8X. So that sort of solves the problem. So this, not right. However, if I did $8 times the number of students, that's now money. Now, adult tickets are 12. Remember, I have to use brackets because that whole thing, 400 minus X, that whole thing was adult. Okay, so that's $4,200, and I can't write that final 0 there. It's not written very well because I'm out of space. Okay, oops. I'll scroll back down, sorry. I hit a space on my keyboard. All right. So we now have money equals money. Now we can go ahead and solve. The first thing we do is use the distributive property. And we can collect our like terms. We put our letters on the left, and we can put our numbers on the right. Now, in this case, you're going to think, wait a minute, I think I've made a mistake because I have negatives. It's okay because both sides are negative. And when both sides are negative, they're going to eventually become positive, so don't worry about that. Had you chosen X to be adults, you would have gotten a positive answer. You would have actually gotten a different answer because obviously the number of adult tickets is not the same as the number of student tickets. So I chose X to be students. I got 150. To get adults then, I just do 400 minus 150. I get 250. So If you had actually let X be adults, you'd be getting 250 for X, but in the end, you still get the same answer. Now we can say, therefore, 150 students and 250 adults went, I don't know, was it a play? Went to, let's see, they're just in, yeah, a play. Went to the play. So this problem is a little bit challenging, a little bit more challenging for two reasons. One, there was no statement. If we read back up here, there was no statement that said like there are 5 times as many this as this. That makes it a bit harder. Second reason it was harder is we had to change one into money. We couldn't just have number of students or number of adults. We had to turn that into an amount of money before we could solve the problem.